Okay, guys, here is part 2 of the field of vision journal pages. So it says number 3, the field of vision of many animals, including people, is divided into a binocular field of vision and a monocular fields of vision. In the binocular field of vision, we can see an object with both eyes. Binocular vision helps us see in 3 dimensions and tell how far an object is. In a monocular fields of vision, we see with just one eye. The diagram shows appropriate fields of binocular and monocular vision for different animals. So think of when you go to get your eyes tested with Nurse Josette or maybe at your pediatrician, they might have you cover one eye. That is to test your monocular vision for that eye. And then they'll have you look with both of your eyes. So that's kind of how they judge whether you need, like for Miss Mold, she needs glasses. So that's how they'll judge what prescription each of my eyes should be. So they test my binocular and my monocular vision in both of my eyes. So let's look at the examples. So they show us humans. So from the darker blue from here to here is my binocular or a human's binocular field of vision, which is 140 degrees. And they show here is where you can see with your right eye a little bit extra. Here's your right monocular field, and here's your left monocular field. Okay, here is your binocular field for a sheep. So here's that dark blue area. So they can only see 62 degrees with both eyes. But their monocular field of vision is much greater than a human's for their left eye and for their right eye. It's very similar for the fox. Their monocular field of vision, where they could see only with one eye, is much greater than their binocular field of vision, which is only 40 degrees. Okay, so they want us to complete the table. Now, there's a few things that we have to know. So for the human, we know the binocular field of vision is 140. And they're giving us the right side. They're telling us that this right side is 20 degrees. And my total field of vision, because it is a straight angle, is 180 degrees. So how can I figure out what this left side can see? Well, I can do 140 degrees plus 20 degrees, which would give me 160 degrees. Then I would subtract that by the total field of vision, which is 180 degrees, minus 160 degrees, and you would get 20 degrees. So a human's monocular field of vision is 20 degrees. Okay, and you know Miss Mold's complaint with everyday math all the time is they never give you enough room for scrap paper. So I'm going to keep doing what I was just doing and doing it up here. So I'm actually just going to erase this so it doesn't get in our way. Maybe I'll change the color so you guys can see better. Okay, so let's look at the sheep. So the sheep's binocular vision, so what they can see with two eyes, is 62 degrees. And they gave us what they can see with their left eye, which is 104 degrees. Their total field of vision is 270 degrees. So if I did 62 degrees plus 104 degrees, I would get 166 degrees. Then I would subtract that by the total vision, which is 270 minus 166 degrees, and you would be left with 104 degrees. So that's what the monocular field of vision for their right side is. Okay, let's do it for the fox. So they're giving you all of the fields of vision for the fox, and they're asking you what the total field of vision is. So you would do 40 degrees plus 110 degrees plus 110 degrees, and you would get 260 degrees. Okay, the rock dove, they're doing the same thing. They're giving you all of the fields of vision, and you have to find the total field of vision. So you would do 24 degrees plus 148 degrees is what they could see with their left eye. And their right side is also 148 degrees. And if you added all of those up, you would get 320 degrees is what they're able to see in their field of vision, much greater than a human's. Okay, let's keep going with the next animal is a horse. So it says their binocular field of vision is 65 degrees. But we don't know what their monocular field of vision for their left side is. But we do know their right, so I'm going to add it. So 146 degrees. And if I did 65 plus 146 degrees, I would get 211 degrees. And I would subtract that from the total field of vision to find out the monocular field of vision for the horse's left side. So 357 degrees minus 211 degrees. And if you did that, you would get 146 degrees. Now, you're probably noticing a pattern here that the monocular field of vision for the left side is usually the same for the right side. So as far as all of our examples go, they're all the same. So sometimes you might not even have to do the math. So for the cat, you're going to have to do it because they give you the monocular field of vision and the total field of vision, but they don't give you the binocular field of vision. So you have to do 30 plus 30, so the right and the left side, which equals 60, and subtract that from the total field of vision. So 200 degrees minus 60 degrees, and the cat can see with both eyes 140 degrees. The next one, a harbor seal, we have to find the total number of degrees. So we're going to add up all of their fields of vision. So it's 67 degrees for their binocular. Their monocular for the left side is 71 degrees, plus the right side, which is also 71 degrees. And if you added all that up, you would get 209 degrees, which is their total field of vision. Now, for the dog, you can see they're missing their monocular field of vision for their right side. But it's going to be the same as their left side, so you don't even need to do the math there. You can just fill it in because it's 90 for their left side, so it's going to be 90 for their right side. You should always double check your math, but it's the same for the left and the right side. Okay, the owl, we don't know the monocular field of vision, but we know the monocular field of vision. So I can do 20 degrees plus 20 degrees, so the left and the right side, and you get a total of 40 degrees. So you would take 40 degrees and you would subtract it by the total field of vision, which is 110 degrees, and you would get 70 degrees. And let's do the red-tailed hawk. So the red-tailed hawk, you have all of the binocular and monocular field of vision. You just need the total field of vision. So you would do 33 degrees plus 123 degrees plus 123 degrees. And if you added all of that up, you would get 279 degrees. Okay, the next video is going to be on finding the distance using fractions. So work on that journal page. It's 276, and then watch the next video.